This is the second screencast related to section 4.5, graphs of sines and cosines. Now we need to look at the graph of the cosine. So back on the file that we opened up, the link that we opened up in the previous screencast on graphs of sines, we need to now look at the graph down here on the bottom, which is going to tell us about the graph of the cosine. Again, let's recall that what we're looking at on the left-hand side is the unit circle. So this is circle center at the origin, radius 1. And we have an angle in standard position. The positive x-axis is the initial ray. The terminal ray is drawn here as the diagonal. We look at the point where that terminal ray crosses the unit circle, and that x-coordinate is the cosine and the y-coordinate is the sine. Again, remember, you think of this as the adjacent side divided by the hypotenuse for the cosine. Well, if the hypotenuse is 1, you divide the adjacent side by 1, it's just the adjacent side. So the cosine of that angle in there is the length of that horizontal side. So now we're going to try to draw the graph of the cosine curve by that horizontal length is what I want to be the y value over here. So the red length here will be the same length as the red over there. The x-coordinate over here is going to be whatever the angle is equal to. You can also think of it as whatever the radius, the radius is 1. But because the radius is 1, the arc length over here is equal in value to the angle in radians. The arc length is supposed to be the radius times the angle, but if the radius is 1, the arc length is just equal to the angle in radians. So the x-coordinate over here will be the angle over there, and the y-coordinate over here is the x-coordinate of that point, and hence it is the cosine of that angle. As we click here and let it animate, we can see that the x-coordinate, it keeps getting bigger and smaller. There it is down at negative. Now the x-coordinate is positive, up as high as positive 1, down to 0. The x-coordinate is negative 1, back to 0, and up to positive 1. And as that angle keeps going around and around, the cosine keeps going back and forth between 1 and minus 1. The x-coordinate here on the unit circle keeps going between plus 1 on this end with an angle of 0 or 2 pi or 4 pi or 6 pi, dropping down to 0, dropping down to minus 1. Of course, you're down at minus 1 when the angle is pi, or 3 pi, or 5 pi, or any odd pi. The cosine will be 0, like right now, and right now, when the x-coordinate is 0. That is when you're at an angle of pi over 2 up at the top here, or 3 pi over 2 down at the bottom there. Okay? And you can watch over here as there's negative values of cosine because the x-coordinate is negative, then we get back up to positive values, and it all repeats again. Again, like with the sine curve, I'm not drawing the rest of the graph. This graph would continue on. It would start headed downhill from here and just repeat this up and down cycle. The cosine is a periodic graph because it repeats itself. The period of the cosine is the length along the x-axis to make one complete cycle. And I can see from here, going down, going back up again, here we go, right up to there, is from 0 to 2 pi. And I would say that the period is 2 pi. So there's the graph of the sine and the cosine. Up and down here, sine on top, cosine on bottom. Both of them generated by looking at the unit circle. For the cosine, I'm looking at the x-coordinate. What is it doing as the angle gets bigger and bigger? For the sine, we saw that we looked at the y-coordinate as the angle got bigger and bigger. So there's the quick overview of where the cosine curve comes from. Next, we'll move on to transformations of the sine and cosine. What happens when you, or how do you shift them around? What do you need to do to the formulas to get these graphs to move? Anyway, we'll be back with those.